We are going to be simplifying fractions, and when we're simplifying fractions, that means that we're going to write a fraction in its most simple terms, or in its smallest terms. When we're doing this, we're going to still create a fraction that has the exact same value, meaning it is equivalent. And when we were working with equivalent fractions, we had to do the same thing to the numerator as we did to the denominator. So if we multiply by 2 when we were creating equivalent fractions, we had to do that in both. That had to match. Now when we're simplifying fractions, we're going to be dividing both the numerator and the denominator by the same number. So if we choose to divide it by 2, because both numbers can be divided by 2, that again has to match, creating an equivalent fraction. If we look at the two examples we have here, we have 3 out of the 6 written. We also know that we could split it into, rather than 6 total pieces, we could split it into 2. One of the pieces is shaded green out of the 2 total pieces. Well, if we think of this in terms of division, we can divide both 3 and 6 by 3. And when we do that, 3 divided by 3 gives us 1, 6 divided by 3 gives us 2. As long as this matches to both the numerator and the denominator, we're creating an equivalent fraction that's in smaller terms. Once we get to the point where we can't divide them anymore, that means it's in its simplest form. Just like this fraction here, 25/50ths. Both of those numbers we can divide by 25. Think of quarters. If we had 2 quarters, 1 quarter is worth 25 cents, 2 quarters is worth 50 cents. So 25 divided by 25 is 1, and 50 divided by 25, that's 2 quarters. So 1/2 would be in simplest form. So let's practice this a little bit. We've got a bunch of examples, 4 and 6. Our divisibility rules will be helpful, and when we look at these two numbers, they're both even. Any even number can be divided by 2. And again, it has to match in the numerator and denominator. 4 divided by 2 gives us 2. 6 divided by 2 gives us 3. Now when we look at this, 3 is a prime number, 2 is a prime number, and 2 does not go perfectly into 3. We can't divide them by anything else, and dividing by 1 isn't going to change the value of it. So in this case, 2/3 is the final answer, because we can't divide them into any smaller terms. If we look at B, 12 and 15. 12 is even, 15 is odd. So that means we cannot divide by 2. So if we check 3, 12 we can divide by 3, and so can 15. If we divide them both by 3, again, that has to match. 12 divided by 3 gives us 4, 15 divided by 3 gives us 5, and we have a smaller fraction. We always want to check, can we simplify any farther? 4 we can divide by 2, but 5 we cannot divide by 2. And no other numbers can be used to make them in smaller terms, but still nice whole numbers. So 4/5 is our final answer. If we look at 6 and 10, both are even numbers, meaning we can divide them both by 2. A lot of times, if we see 2 even numbers, 2 is a great place to start. Sometimes we can pick a bigger number, but 2 is a great place to start. 6 divided by 2 is 3, 10 divided by 2 is 5, 3 and 5 are both prime numbers, and we can't divide either of them by that smaller digit of 3. We could divide 3 by 3, but 5 we cannot divide by 3 to get a nice number. So 3/5 is our final answer. Let's look at E. We're going to skip to 1. E, 4/12. This time, again, we see 2 even numbers. There are a couple different ways we could do this one. We're going to try them. The first way is to say, well, 4/12. We can divide both of them by 2 because they're both even. If we do that, 4 divided by 2 is 2. 12 divided by 2 is 6. And now we have still 2 even numbers. Because of that, we can simplify it even farther. We can divide them again by 2. It wasn't in simplest form yet, and that happens quite often. This time, 2 divided by 2 is 1, 6 divided by 2 is 3, and now we can't simplify any farther, so 1/3 would be our answer. When we were doing this, we divided by 2, and then we divided by 2 again. If we look at our original numbers, 4/12, there's a bigger factor that they both share. Both of these can be divided by 4. 4 would be called the greatest common factor because it's the biggest factor that they share. And when we divide that, 4 divided by 4 is 1, 12 divided by 4 is 3. And you'll see that this time, rather than it being broken into 2 steps, it was just 1 step. But we still got the same answer because it's in its smallest terms. If we go back to D now, 3 and 9, it may be easy to think, well, we can't simplify it because 3 is prime. But that's okay that it's prime because 9 can also be divided by 3. We can always divide a number by itself and get 1. And since 9 also can be divided by 3, we can simplify it, giving us 1/3. Now that they are both prime numbers, we can't simplify it any farther. If we look at 2/4, both even numbers, we can divide them both by 2, giving us 1/2. For G, both are even numbers. So when we divide, do those have to be by the same number? Yes. It has to match. 6 divided by 2 gives us 3. 8 divided by 2 gives us 4. Because we're doing the same thing to both the top and the bottom, we're treating them equally, we are going to get an equivalent fraction, in this case because we're dividing in its simplest form. 3 is prime, meaning we can't divide it by anything other than 3 in itself, and 4 cannot be divided by 3, so we can't simplify. If we look at 9 and 15, both of those can be divided by 3. And when we do that, 9 divided by 3 is 3, 15 divided by 3 is 5, both of which are prime numbers. We can't divide them any farther by the same number, so this would be our final answer. 9/12. Odd number, even number, so 2 wouldn't work. So then we want to check 3, the next one, which happens to work for both of them. 9 divided by 3 gives us 3. 12 divided by 3 gives us 4. We can't divide them any farther, but we always want to check because sometimes we can. And then in our last example, 2 even numbers, so a good go-to is dividing them by 2. When we do that, we get 2/5. We can't divide 2 by anything other than 2, and 5 cannot be divided by 2. So this is in simplest form. Even if you've done one simplifying step, double check to make sure if you can do another one, because we always want to go as far as we can go to get that fraction in its smallest terms. What we do to the numerator, the top, we also have to do the exact same thing to the denominator. So we have to divide both the top and bottom by the same number.